Hello everyone, how are you doing today? Welcome to a video tutorial learning about graphing linear inequalities in the form y is greater than some constant c. And this could mean y is less than some constant c. But anyways, the idea is there's only a y variable, there's no x variables. How do we deal with that? Well, let's look at an example and really dig into this idea. So we're going to play around with the inequality, all the y values greater than -3. Okay, we're going to graph it. We're going to think about solutions to that and what are all the points or ordered pairs that fit that scenario. All right, let's start off with points, ordered pairs that work, or ordered pairs that an ordered pair is just an x and a y value that are true. So ordered pairs that have a y value greater than -3, well, let's just list a few out. So we could have 1 and 4. That's got a y value greater than -3. We could have 5 and 0. 0 is greater than -3. We could have 8 and -2. And we could have -6 and -1. All right, I'm going to go ahead and plot those 4 points just so we can see them. So 1, 4, it's going to be right here. 5, 0, it's going to be right here. 8, -2, 6, 7, 8, -2. And -6, -1. 5, 6, -1. Okay, now let's take a look at some that are not true. So ordered pairs that are not true. Again, we're just kind of building our understanding. So we're looking for points x and y that do not fit that inequality of y values greater than -3, that are not true. So we've got, let's do 5, -6. -6 is a y value, and that is not greater than -3. Let's do 0, -10. Let's do 8, -4, and let's do -7, and we'll do -3, -7, -3. I knew -3 because -3 as a y value is not greater than -3, so it's not a solution. So let's graph these points and kind of see what we got going on. So 5, -6 is right down here. 0, -10 is going to be right here. 8, -4, it's going to be right down here. And -7 and -3 is going to be right here. Okay, you may not see a clear picture, but we're starting to piece together where on my graph representative are solutions and where on my graph is not representative solutions. But let's kind of think about this a little bit different again here. So we're going to separate all that. We got some points that are true and some points that are not true. Let's dig a little bit more generalized here. So we know how to graph horizontal lines. What if I asked, graph the equation y equals 3? Well, that is all the points that have a y value equal to 3. And so if I wanted to graph that, I would say, okay, well, all those values are at a y value, whoops, we're -3. So -3 is right here for y, and we would draw a nice horizontal line through that point, right? What we have here though, so let's go ahead and graph this. This line right here, we're going to graph the line y equals -3. So there's the line y equals -3. And look at that line actually kind of fits our point. Above that line are all the y values, the points that have y values that are greater than -3, right? So if I was to shade this area above the line, that shaded area represents all the points. You can see even the points that we found. All the points that have a y value in it greater than -3. On the flip side, on the other side of that green line, down here are all the points, and we found a few of those, all the points that have a y value less than -3. So hopefully you're getting a really good idea. If we're dealing with linear inequalities and there's no x variable and they're just in the form y is greater than or less than some number, we're dealing with a horizontal inequality. So if we're actually going to graph just this inequality here, I do need the line y equals -3, but it's not equal to -3, so I would actually make a dashed line. There's my boundary line, and we would shade up because I want all the values greater than -3. So that blue would be the graph that represents this particular inequality. So hopefully that's a helpful idea for you. Again, it's related to horizontal equations and horizontal lines. Horizontal inequality, we still need to find that horizontal line, the boundary line. Figure out if it's a dashed line or if it's a solid line based on the inequality, and then shade up or shade down based on the inequality as well. So it's the same thing that we've been doing as we've been graphing linear inequalities. It's just a little bit weird because there's no x variable, and so it trips students up sometimes knowing what to do. But hopefully this is a helpful idea for you to see linear inequalities, see how they relate to equations, and see how we graph all the possible solution sets when we have a horizontal inequality like this one.